So in this particular case, so we have parallel lines within polygons. So state whether or not the dashed lines are parallel. Challenge, can you determine this in more than one way? And the answer is yes, right? So there are several ways to go about it. I tend to like the CIAs the most, in my opinion. So my goal is going to be to focus in on somehow finding this one and this one. And why is that? Because I know if this is the transversal connecting these two lines that we're not sure yet if they're parallel or not. We're trying to prove that, right? We know that they are CIAs. That is not debatable. It is debatable whether or not they add up to 180, right? So that's what we're going to try to prove. Okay. If they add up to 180, we're good. We can say that the dashed lines are parallel. So now you need to use your skills, right, on inscribed polygons to come and figure out all these angles here. And I'm going to approach it this way. I'm going to look at this shape right here that's created by that dashed line. So maybe let's call this X here. If I know X, I can find D, because remember there's an interior angle here if you consider the big polygon. So I will find that interior angle, subtract X from it to figure out D, and then I'm going to approach it from the top here. I'm going to use this inscribed triangle to figure out B, which in turn is going to allow me to find C. Okay, and once I have D and C, then I'm good to go. Where do you want to start? I'm going to start with a triangle perhaps, and further, actually, before you do anything else, count. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we have a nonagon here at play. And let's go and figure out, I'm just going to look at my key to make it a little bit faster. Did I post this one? Yeah, it was posted. What if I can't find it though? Oh, here it is. Okay. So the interior angle, that would be A. So I'm asking you for it in this case. That would be a 9 minus 2 times 180 degrees over 9. That's 7 times 180 over 9. And that ends up being 140 degrees. So something I asked for anyways, 140, there we go. We need it regardless. Now we'll figure out B here. B is 180 minus the one interior angle, and we're going to split that in half. So we end up with 40 divided by 2, that's 20 degrees. So now I know that that's 20 right there. Maybe I'll use a color. I know that that's 20. So let's figure out C right away. How do we find C again? I will take the interior angle minus angle B. Okay. So I'm going to go 140 minus 20. So angle C is 120 degrees. It's important. That's one of the green ones. Maybe you shouldn't have used both the same color, but it's still, right? So we know that this is 120. Maybe with a pen, you just go in here and just say that this angle here between the dashed and one of the sides is 120. So I need this to be 60, right? It's fairly obvious. I need this to be 60 in order for me to say that they're parallel. So let's come from this, using this one. This is a pentagon, isosceles pentagon, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. It's not a pentagon. Wake up. What is that? Hexagon. That's what it is. You think I did that on purpose? Maybe. Sometimes I do that. You'll never know. Let's figure out X. Okay. Angle X, how would you find it? I didn't give you a formula for this one, right? But there's a pattern. What is the sum of interior angles for a hexagon? I don't know, it's 720, right? You can use the formula, right? Sum for a hexagon. I'll just do that on the side, so when you look at your notes, there's lots going on here, I know that. 6 minus 2 times 180, that'd be 4 times 180, and that's 720 degrees that we're looking at in here. Maybe write it in there. So similarly, if you know the pattern, right, we're going to go 720 minus, how many interior angles are there? 1, 2, 3, 4. There are 4 interior angles of that nonagon that I need to take away. So 4 times 140, and always divide it by 2, because you're finding both of these base angles that remain, and we know they are the same. Okay. So I think I have that. Yeah, it is on the key. So that'd be 160 divided by 2. That gives me 80 degrees. I'm running out of colors, but I can do this one. Right, that 80 is this one right here. And now I will find angle D. Angle D is an interior angle of the nonagon minus angle X, right? Angle D is 140 minus 80, and that will give me 60 degrees. Okay, that's the other green one right here. There one there. And I'm going to write it in there. I'm going to take the 60 and actually write it in here. And I don't have a whole lot of space to make my concluding argument here, but I'll just use this spot right here. I will say lines are parallel. You may use this notation if you like, because consecutive interior angles add up to 180 degrees. Okay, so just show me that C plus D is equal to 120 plus 60, and all of that is equal to 180. There we go. That's basically the long road to prove something like that. There is at least one other way that I can think of that you can solve this. If this is 120, right, then this is also 120 here. So we could do 360, right, minus 120, and then divide the rest by 2. However, if these dashed lines, if one of them is a little off, right, then you can't use it. So I would just say stick with this method where when you see a dashed line, you approach it from this side, right, to move in, and for that diagonal you approach it from the top, coming in that way. So I wouldn't work between dashed lines. I wouldn't do that, because there might be an issue there. Okay. Is that good? Clear as mud? Yeah? No, I hope it's clearer than that. Okay.